moment of inertia of a right circular solid cone about the central axis. Let's say this is a right circular cone, solid cone, radius is r, height is h, and we have to find the moment of inertia of this cone about this axis. So what we do is, generally as we have done earlier also, mass of this is m, radius is r, height is h. So volume is, we know, that is pi r square h by 3, that is the volume of a cone, 1/3 that of cylinder of radius r, height h. So what we do is, that is very first thing, at a distance y, we take a small disc. So we take a section. So this section is obviously is like a disc, small cylinder of, what is the thickness? Thickness is dy. And what is the radius? Radius we are taking it as x. That is at y distance from here, we have taken a disc of radius x and thickness dy. So now obviously that is this triangle, this bigger triangle and this smaller triangle, they are similar. Or we can say that this triangle, bigger triangle and this triangle, they are similar. Or we can say that is tan theta, be it this triangle or be it this triangle, that is going to be same. So it means that is r by h is equal to x by y, r by h is equal to x by this is y, r by h is equal to x by y. We also know that is mass per unit volume is density. So we have taken the density of this as rho, that is we have taken the density as rho. So mass is m upon 1 by 3 pi r square h, that is rho. So now how we are going to proceed is, we are going to find the mass, that is dm of this general disk, which is at a distance y and its radius is x. We'll find its moment of inertia of this disk. We know that is m into r square by 2, that is the formula. So over here it come out to dm into x square by 2, that will the moment of inertia of this disk about this axis, about central axis, we know it. Then we will accordingly will integrate that, because that is what, this disk plus disk plus disk plus disk and so on, that is we can make a right circular cone. Right circular cone is nothing but is a compilation of disk one over the other of gradually increasing radii, right? So at a distance y, we have taken a disk, thickness dy, radius x, and now we are going to find its moment of inertia. First is mass. Mass is what? That is dm. Radius is x and thickness is dy. So dm comes out to pi x square, that is area into height. Area into height, that becomes volume. Volume into density is mass. So moment of inertia of this small disk about this axis is, you will know that is a pattern is mr square by 2. So moment of inertia of this small disk about this axis is going to be dm into x square by 2, right? Now what we see over here, that is when we say dm, it comes out to pi x square dy rho x square by 2. Now we wish to find the moment of inertia of this whole cone about this axis. So it means we have to integrate, we have to add, we have to integrate the moment of inertia all these individual disks about this axis. So we have to do integration. Now if we have to do integration, we have two variables, one is x, the other is y. But these, they are interdependent variables, that is there is some relationship between the two, between x and y, defined by this function. So now what we can do is, one option is we substitute x in terms of y, or the other is we substitute y in terms of x and then accordingly take the limits. Now let's say we express x in terms of y. So r by h into y is x. So x is replaced by this in terms of y. X is equal to r by h into y. This comes instead of x, so this comes over here, x square, this comes over here. Dy is dy, rho is rho, x square by 2, x once again replaced by r square by h square, y square into 1 by 2. Now it is, everything is in terms of y. So y is going from 0 to h. Limits they are going to that is y, how the y is varying from 0 to h. So limits they are 0 to h. Now the other option is, instead of replacing x in terms of y, we can also replace y in terms of x. So obviously y into r by h is equal to x. Y into r by h is equal to x. So dy by dx is equal to going to be equal to h by r, dy is equal to dy into r by h is equal to dx, or dy is equal to h by r into dx. So Iy becomes equal to, that is what was that over here, we know this. Over here, now we are going to replace y in terms of x. So pi x square remains like this, dy is what? Dy is h by r dx, h by r dx. Rho remains like this, x square remains like this. Now the x is varying from what to what? X over here is 0, it increases, and finally it becomes x is equal to r at the final disk over here, which we consider it is integral of all these moment of inertia of all the disks. So x goes from 0 to r. So that comes out to pi x square h by r dx rho into x square by 2, and that comes out to be 3 by 10 mr square. Whether you do it by this or you do it by this, solving this, you will get the same answer as 3 by 10 mr square. In case you intend to do it, let's do it over here. A simple integration. So this comes out to be pi comes over here, pi h by r is here, h by r also taken out, rho is taken out, so 2 is taken out, so this is x square, so this is x4 dx, I y dash is equal to this thing, so this comes out to be pi by 2, h by r rho, this is going to be x5 by 5, that is 0 to r, 0 to r, so this comes out to be r raised to 5 by 5, so this comes out to be now is equal to pi by 2, h by r, rho is what? Mass upon volume, 1 by 3 pi r square h into r5 by 5, pi and pi they get cancelled, 3 is here, 3 goes in the numerator, h and h they go off, let's say we can remove pi also. So this is r cube, this is r5, so r cube and this r5, so this comes out to be this thing. So this comes out to be 3 by 2 into 5, 10 into mr square. 3 by 10 mr square. Similarly over here is same way, simple integration, you can get the same answer.